before. All right, a power function is a function of the form y equals a times x to the b, where a is a real number, b is a rational number, which can be written as a fraction. We've been working with them already. Here's an example of a power function. Or here's another example of a power function. Something like that. We've been working with them. Composition, this may be new. You may not have seen this before. I don't know if you do this in geometry at all. But the composition of a function g with f is g of f of x. Ooh, say it. G of f of x. Those parentheses kind of mean of. And that's what we're going to do today. So this pretty much is saying find the value of f of x and then plug it into g. That's what it's really telling you, and that's what we're going to work with today. So really, g of f of x means you find the value of f of x with the given value of x, and then you plug whatever that poop is, or output, into g. Okay? Still? Okay. Anyway, I'm glad we still get a chuckle out of the word poop. So let's just practice what we're part of compositions here. Not only is it written like that, but you can also say, all right, this is just a way of writing the fact that I want you to add f of x and g of x. So you just write it out. Whatever the value of f of x, this function right here, you write 5x to the 1/3 plus negative 11x to the 1/3. That's what it's telling you to do. Add the f function plus the g function. Yeah? Are we done yet? No, because we can combine those because they're like. So how many do we have altogether of x to the 1/3?
6.
Yep. And that's it. That's all you can do. Okay? This one is saying subtract. So again, you write whatever the function of f is minus the function of g. And minus minus becomes what? Plus. So how many, oh, I forgot the x here. How many x to the 1/3 do we have? 16x to the 1/3. So far, so good? Yes? All right. It says find the domains. Give me the domains of f plus g and f minus g. Do you remember what domain is? Yes, it's the food. It's anything that x could be in this function and anything that x could be in this function. So these aren't too bad, but let's go back and refresh our memory from chapter 5. Okay, is this an odd or an even exponent? It's odd, right? So is that going to give me like a snake graph, an S graph, or is it going to give me like a parabola, sort of? Yeah, and since this is negative, which direction is it going to go? Like this or like this? Okay, so I know it's sort of like this, right? Sort of. I don't know exactly. Do you remember this from chapter 5? So let's think about if I have a graph like that, what kind of x value could go into this? Is there anything that x can't be? No, because it goes forever, right? So the domain is what? All reals, okay? So for, let's see, the first one, f plus g. For f plus g, the domain is all reals, or you can just use that symbol. The real symbol? I don't know. Have you not seen that before? Oh, your life's just not complete. Really? Oh, I showed my kids that. What do I have in 8th grade? Darby's seen it before.
I haven't seen it.
But you may not remember. But Megan, do you remember? She's like, no. All right. It's just like the paragraphs, 2 lines, and then you make a big R over it. That's real. That's the symbol for all reals. Okay? So then, how about this one? 16x to the 1/3. Is this as an odd, and it's positive, so it's a snake that goes up? Is there anything that x couldn't be? No. So f minus g is All reals. 2 lines and a big R. Pardon me?
How do you know if you're supposed to F or G? The function F or G and figure out what the graph is.
What does this mean? Multiply them. So I'm going to write 8x times 2x to the 5/6. Can I rewrite it because it's multiply?
Yeah.
If it helps you, you certainly can. 8 times 2 is what? 16. What do I do with this business here?
X 11.
Ah, how did you get 11?
11.
6/6, right? It's a 1 there. I'm going to write it as 6/6 because I add the exponents when I'm multiplying.
Oh, you add it?
Yes, and so to add, you have to have a common denominator, so I got to make it 6/6. So it's a 16 to the x, 11/6. 16 times x to the 11/6. Now, just as a fun refresher, can this be written as this? Let's think about it.
Yep.
Is that the same thing? Yes, it is. But you can just write it like that, okay? All right, let's do the next one. This is my answer. F of x divided by g of x, so write 8x divided by 2 times x to the 5/6. Let's start by dividing these numbers because I can. What's 8 divided by 2? 4. What do I do with this business? Make this 6/6. Same base, I can subtract the exponents, so I get 4x to the 1/6. Okay, and you want the y variables. And you're doing a function. So you push enter. Oh, there's y1. Look at that. There's y1.
Go to function.
Yes, because we're working with functions. Are you there? Push y1, and then plus, go back and get y2 the same way.
No. Shoot.
You with me?
Yeah.
And then add it.
Yep. Okay, I know it's hard to see here. And then you add it, and then you can graph it.
Can you still want the email It worked.
Now, ladies and gentlemen, we're graphing this, yes? So it's going to be a snake going down.
Well, you didn't go down.
There it is.
You gotta go down the list.
Well, yeah.
Yeah?
Oh, you didn't.
I don't want to spend too much time on this, but I think it's kind of handy, especially when you're trying to figure out the domain. Okay? All right, stay with me. Come on. We got a whole back page to do. So let's erase this. Erase all those. And let's go back to this one right here. This is going to be, no, let's do this one instead. It's easier. It's not such a big stretch. The 4 makes the snake stretch out, or the parabola kind of get tighter. Let's just put this one in and see what the graph looks like. 4 times x to the 1 divided by 6. Is this going to be a parabola or snake? Like a parabola. I shouldn't call it a parabola, but it's like a parabola, right? And it's going to go up because the leading coefficient is positive. So graph it.
Oh, this looks weird.
But wait a minute, I'm only seeing part of it. Do you know why? We have to think about this.
Not all real.
If I write it like this, and I have an even exponent or index, I cannot stick a negative x in there. If it's even, I cannot have a negative x, right? So the only x values I can have to be positive. When you have an even, like for instance, you can't take the square root of a negative number, right? It says, can't do that. But you can take the square root or the cube root of a negative number, correct? So this is an even. Therefore, the only x's I can stick in there have to be greater than or equal to 0. So the domain has to be what? Greater than or equal to 0. So for this one, x has to be greater than or equal to 0 because this is also an even. This is also an even. And for this one. So you have to think about that. Again, you can't just memorize this or this or this or this. You have to think about it. Okay? Okay. I'm going to write you can't have a negative x in an even root. Okay, can we turn it over now? Even root. Okay, domain of each. This is where it gets a little tricky. So let's write the domain of f of g of x. That's the first one we did. This one here. I had to think about this one. It's all reals except x can't be negative 5/4. Let's think about why that might be.
That's a good point. How would you ever know that?
I'll show you.
What does that say?
It's all reals except x can't be negative 5/4. Does anybody have an idea why that's the case? No? Okay. Has something to do with this. If I stick in negative 5, just stay with me and listen to this explanation. If I stick in negative 5/4 here, that's going to make this function value 0, right? And when I stick it into here, I can't have a 0 here. Because 0 to the negative 2, this would be, in the bottom, let me explain it like this. This would be like this. 6x squared. Can I have a 0 in the denominator? No. Can't have a 0 in the denominator. So when there's a negative exponent here, you have to think about, wait a minute, I can't have a 0 in the denominator, so this domain can't be negative. Practice it. It's not like you got to get it right away. You'll think about it, you'll see it if you keep doing it.
Wait, so basically you don't want 0?
Yeah, if you are putting a function into a function with a negative exponent, remember negative exponents are written on the bottom, and I can't have a 0 in the bottom of this function, can I?
What about stuff that like is wait, doesn't have a denominator?
Then it could be all real numbers. We'll just see. We'll see. You have to go by each function in particular. Okay? G of f of x, the second one here, is all reals, but I stuck f into g, and I know x can't be 0 here. So it's all reals except for 0. I can't have 0 as x in that function. X can't be 0. And then the last one, g of x. Is there anything that x can't be since I'm sticking it inside itself? There really isn't. There's no denominator that can't be 0 in that. Okay, so it's all reals. The domain's kind of weird.